Let us solve the exercise number 2 in the part A of a data structure lab. In this exercise, we are supposed to write a program to sort a given list using insertion sort. So let's first understand what is insertion sort, and we will then be able to write the program. So the insertion sort is the idea of arranging the item in the ascending order by inserting the items at a proper location. Now, we are all familiar that whenever we keep our currency notes inside our wallet, we usually arrange them in a particular order. Either we keep the highest facing currency first, followed by the lower. This is the decreasing order. Or sometimes we keep them in the ascending order. So we keep the 5 rupees first, then we keep maybe 20 rupees and maybe 50 rupees and 100 rupees and so on and so forth. Now, suppose if I have to place, suppose I have these many currency note with me inside my wallet, and if I want to keep the rupees 10 inside this uh, list over here, then what am I supposed to do? So generally what I will do is I will move the notes in such a way that there is a space to accommodate this 10 rupee note, and then I will place the 10 rupee note at proper location. That means after 5 rupees I'll keep the 10 rupees, and then maybe 20 rupees and 50 rupees and so on and so forth. Suppose if I have to place the 200 rupees, so what I'm going to do is I will first move the 2000 rupees note, assume that that note is still being used, and then I am going to keep the 100 rupees note at this particular place, then followed by the other. So that means to say that whenever I try to insert a new currency note inside it, I will first make a space so that the note can be accommodated at that particular location. The same idea is being used up here. Suppose if I have to bring this number 2 at this location, that is at the beginning of the list. So I have to make a provision here so that this particular location is empty and this 2 can be brought over here. Now, when I say I have to make a provision, it doesn't mean that I will override the 5 from the list. That is not allowed. So I have to somehow find or devise a technique in such a way that this particular element, which is supposed to be there at the first location, must be brought at the first position by inserting it at a proper location. So suppose if I have to bring the element 3 over here, I have to bring this one at a particular location. Suppose if I have to bring this 1 here, I have to insert it at the proper location. How do we do that thing? So the idea here is we make a provision such a way that the place where the item has to be inserted is first vacated, or it is made blank, and the item, whichever item is required, we will bring them and keep them here. So in other words, we will insert them. This is what I'm doing. I'm trying to insert it at the proper location. Thereby I achieve the alignment or the sortedness of the list. So let's go ahead and let's understand how this algorithm really works. So here what we do is we start from the first element. We assume that the first element is in the proper order. So it is there at the proper location. And we then assume that the remaining list of items are not in the proper order. Now this is just an assumption. Then to justify that our assumption is correct, we start comparing this element with the remaining element in the list. Suppose I'm arranging in the ascending order. So suppose if I find that there is one element which is smaller than the given element. So what I'm going to do is I will swap them their location. So I will bring this one here and I'm going to bring this one to the other location. So in other words, first I'm going to keep this any element, either 5 or 4, at a temporary location, and then copy this element to the other location and bring this one back to this position. Okay. Now what I have here is I assume that the first two elements are in the sorted order. If you ignore the remaining element, or if you don't look at the remaining element, you notice that 4 is less than 5. So they are in the ascending order. Now let's take the next element in the list, and the next element in the list is 2. Now I have to insert it at a proper location. So how do I do that thing is, first I compare. So I start comparing. Now my next location is, I start comparing. I have done up to this point. I will go start from here. So I will compare this with the previous element. So what I notice is, this element, that is the first element, is smaller than the is greater than the second element, or in other words, there is a smaller element after the larger element. So I am going to swap their location. So how do I swap their location? There are many ways in which you can do it. I will first copy this 2 at the temporary location, and then I will bring the 5 here, and then 2 at this location. Now, what I have here is the remaining two elements. So what you notice here is, again, I start comparing this element with the other element. So I brought this element 2 was here. I brought it to this location. Now I again compare these two elements. What I notice is 4 is larger than the 2. So I swap their location again. So what I'm going to do is, I'll copy this 2 at this location, at a temporary location, copy this 4 here. This is called as swapping, and I bring this 2 to this location. So in this process, what you notice is, I'm inserting the element at a proper location. Now, up to here, the array is sorted. The other part is not sorted. So let's go from this location. How do we place 3 at proper location? I compare 3 with the previous element, that is the 5. So I find that 5 is greater than 3. So what I'm going to do is, I will swap their location. So first I copy 3 to the temporary location, move the 5 to the other location, and bring 3 to this location. That is not the end of it. So I then compare this 3 with the previous element. So what I notice now is 3 is smaller than 4. So again I swap their location. So I first copy this 3 to a temporary location and 4 to the next location, and bring this 3 to the proper location. Now that's not the end of it. Again I try to compare this 3 with the previous element, but I notice that they are there in the proper order. So because they are there in the proper order, so I assume that this particular list up to here is sorted. The same technique is being used in next. So if I look at the next element over here, 10, I notice that 10 is already greater than the previous element. In this case, there is no need to bring this 10 to any other location, because it is there at proper location. So what is this insertion all about? Insertion is, you get the element and insert it at a proper location. That is why it is called as insertion algorithm. So let's go ahead and let's try the insertion algorithm. I will bring this list back to the original uh, condition. That is, I think the 3 was here, the 5 was here. I will bring it back to the proper locations, to the first state, so that I can explain it as I code the program. So let's go ahead and let's start the code block. I'm going to start a new program here. I will go here and I will select C, C++ code. Let me go next, and I will give it as insertion. I'm going to just type INS. You can type the whole thing over here. Let me click finish to finish it up. As usual, I need the stdio.h for input and output operation. So I'm going to go with the stdio.h over here. And let's start coding the program now. What is that we are supposed to do is, we are going to write the main program. So let's first write this main now, and then we will discuss about it. Let me assume that I have a array, and array has 25 elements. and I'm going to use the not all the elements of the array. So I will, even though I have the array of 25 allocations here, during the examination, you will sort it with just 5 element. So that 5 element is restricted by n. So I'm going to say out of this, I'm going to use only 5 element there. Then I'm going to use a for loop for inputting the elements into the array, and I need one more for loop. So I'm going to use one more variable j here. And as I told you, when you want to swap the element, you just bring that element here, and then from this place you copy to the other. So I need a temporary location wherein I can copy the element. So with this, let's start the first part of the program. Remember, this is true for any of the sorting algorithm. This step is there. So you first ask enter total number of elements. So why I'm saying this is if you don't know the programming logic, or if you forget the programming logic during the examination, at least write this part, and you will be given some appreciation mark. Again, don't blame me that oh, sir, I wrote this much and I have not got a passing mark. If you just write this much, there is no guarantee that you will get a passing mark. Okay, but you will be given some appreciation mark, not the, you may, if you are lucky, you may get the passing mark. So first what I've done is I have an array over here, and I am saying that out of this array with the 25 element, I will restrict myself to n. So generally in the examination, n will be generally 5. So you won't try it more than 5. Then I'm going to say a printf statement, and I'm going to say enter percentage %d elements into array. So I'm going to say that thing. Okay, and I don't know, I this again can't help it. So this n will be this part. Okay, so this suppose if n is 5, you're going to say enter 5 elements into the array, and I need a for loop for reading that thing. So remember these stories, this is there for almost all sorting algorithms. So if you forget the logic during the examination, write this much during the examination. So percentage %d, and you are going to read the n element into the array. So this is an unsorted element so that you are reading. Now the logic will start. So where did we started? We started, so even though a of 0 is there, we assume that a of 0, forget the number, whatever is there, a of 0, this position is already sorted. That means to say that first element is there at the proper location. So we won't start with a of 0 or I is equal to 0. We will start with the second element. What is the index of the second element? Index of the second element is 1. So we will start from this one. So let me write the for loop here. For I is equal to 1, because we assume that first element is there at the proper location. So it is like, suppose in your wallet you have just 5 rupees with you. That's it. There is no sorting, nothing. That's the only amount you have. You can't place something behind it or something in front of it. This is there at a proper location. The sorting and arranging will come only when you have two nodes with you. Otherwise, there's only one element. So I assume that the a of 0 is there at proper location. So I will start from I equal to 1 till the end of the list. So I have to pick up one element at a time and then insert them at proper location. So I'm going to start I equal to 1, I less than n, I plus plus. So I start from that idea. Let me use the flower bracket. Then what you do is we start from the next location. So we start, I need one more for loop. So we start from this location and we try to insert it at a proper location. So this is what we are going to do. So we will start one more for loop. Let me start the for loop with j. So j is equal to, we start from the location where we have left with. So I'm going to start from j is equal to I. That means to say that remember I started I equal to 1. That means I am confused, or I am I'm supposed to keep this element at the proper location. So I start from here and I will compare it with the previous element. So suppose if let's just assume that you have arranged these two elements properly. Okay, so suppose assume that these two elements are arranged properly. So I will be this. So you start from here, compare it with the previous one. So this is what you are supposed to do it. So let me bring it back. I think I can use it undo for doing it. So I assume that I will start from here and the j will also start from here. Okay, so j will start from the same location as that of I, and where the j will be ending. So where the j has to stop, where the second loop has to stop. Second loop has to stop when you find the proper location. So let me again just copy this one here. Yeah, just make a copy and let me assume that I'm going to just this is for explanation only. Yeah, let me cancel it. Okay. So just assume that this is the scenario. You have the story like this. So just assume that these three elements are somehow magically you have sorted them. Now this element needs to be inserted at a proper location. So what you are going to do? You compare this element. This is the jth element. Okay, you will compare it with the previous element. If this is the jth element, what is this element? This is j minus 1 element. So this is j minus 1. So this is j equal to 3. 3 minus 1 is going to be 2. So if this is j, this will be j minus 1. You compare them, jth element with the j minus 1th element. Okay, if you find that the element at j minus 1, which is the value here 5, if this is greater than the element at j, so the element at j minus 1, if this one is greater than the element at jth location, in that case what you are supposed to do is you have to swap them. Okay, you have to swap them. So let's do that thing. So I'm going to write if element at j minus 1 is greater than the element at j, then you are supposed to do something. Okay, you have to swap it. So let me keep that swapping story next here. Okay, so you are supposed to swap them. That means to say that you have to bring this 5 next and the 3 to the previous location. That is not the end of it. So you brought this one here, you brought this one here, you brought this one here. This is not the end of it. Then again you compare the previous one. So you started j from here. So now you have to take this one as j. So you say you have taken this j, and this one was j minus 1 in the previous step. Now in this step you take this one as j and take the previous one j minus 1 as this one. So in this case, in the second step, what you are doing is j will be 2 and j minus 1 will be 1. So every time what you do is once you swap them, every time what you do is once you swap them, bring this j back to the previous. So this time it was j was here. For these two, this will be j and this will be j minus 1. So every time you're going to do that thing. So let me bring them back to the some of the same location now. So let's come back to this one. So what you're doing is every time you start from j here, okay, if you are swapping it, so that you start from here, this one will be j minus 1. If you are swapping it, for the next round, you take this one as j and the previous one was j minus 1. And the next time this one as j and the previous one as j minus 1. But what is happening here is j is continuously decreasing from 3 to 1. Every step from here to the next one, j is decreasing. J value was 3. Next time j value will become 2. Next time j value become 1 and maybe j value becomes 0, and if you are not controlling it, j will become minus 1. That means it is going outside the array. So you have to see to it that j will keep on decreasing until j reaches 0. So if the j is going beyond 0, then there is nothing. So if you take j equal to 0, suppose if you say j equal to 0, j minus 1 will be minus 1. 0 minus 1 will be minus 1. There is no element at minus 1. So where is your stopping location? So if this is j, this one is j minus 1, correct? And if this is j, this one will be j minus 1. Okay. If this is j, this one will be j minus 1. Beyond this you cannot go, because if you go beyond this, what will happen is, if you say this is j, j minus 1 will be minus 1 itself, which is outside the bound of the array. So when are you going to stop? You're going to stop when the j value becomes 1. In other words, as long as j is greater than 0, you are going to swap the element. You're going to swap this element and you're going to swap this element if it is required. If it is not required, then we will not do it. So two conditions are being put. One is if I of j minus 1 is greater than j. So that means in this case, for example, this is j. If a of j is j of j minus 1 is greater than j minus 1 is 2. If this is greater than the next element, this, if you take this one j, this one is j minus 1. If j minus 1 is greater than this, you will do it. And what is the next condition? Next condition is j cannot go below the 1 value. That means to say that j must be greater than 0. Okay, so let me put that condition also. And there are one more condition, and j must be greater than 0. And every step what we are doing is, so we are taking first this one as j, next time we are taking this one as j minus 1. This is one step. In the next step, what we'll do is, this will take it as j, the next one is j minus 1. That means to say that j was initially j was 3 for the first step. Next step, j is taken as 2. Next step, j is taken as 1. So j is continuously decreasing by 1. How can I write that thing? I'm going to say j minus minus. For every iteration, j value will keep on decreasing. Okay, so I think one extra is there. Let me try that. Okay. So this is the condition. What is that we are doing? If a of j minus 1 is greater than a of j, you swap them. How do you swap them? You copy a of j into this location, temporary location, move a of j minus 1 to this one, and move temporary to a of j. So this is swapping. So let me write that thing. So you keep the a of j at the temporary location, and then you say a of and this is what you have done. So let me show that thing. So let me bring this was the condition, 3 was here. So you bring a of j into the temporary location, then move this a of j minus 1 to the location of a of j. So you move this a of j minus 1 to the location of a of j, and then move this temporary value to the a of j minus 1, this location. So this is what you are going to do. So you are going to say a of j minus 1 is equal to temp. This is what is known as where is it going? So this is nothing but you are swapping it. Okay, done. This is the only logic that we are supposed to do it. See, look at here. What is happening is, initially you notice that let me bring it to the original situation. So this was the condition. So you find that this was j and this is j minus 1. Okay, you know that. So a of j minus 1 is greater than a of j. So a of j minus 1 is greater than a of j, and j is greater than 0. So you do that thing. So what you are going to do is you will swap them. I'm going to just swap them here. Okay. Next, you take this in the second round, because it is j minus minus, j value will be decreased from 3 to 1. So this time this is j and this one will be j minus 1. So you find that j minus 1 is 4 and j is 3. So again you notice that a of j minus 1 is greater than a of j, and j value is greater than 0. That means it is 2. This is j, you know very well, and this is j minus 1. So naturally this is greater than 0. So again, you are going to swap these two elements. So you bring this to the temporary, you bring it here, and you bring it to the next. So in the next round, when this for loop comes back, j minus minus is executed. So j value was, this was the j value. Now j minus minus means this will be the new value of j, and this is j minus 1. Okay, but what you notice, a of j minus 1, it is 2, and a of j is 3. So for this round, a of j minus 1 is not greater than a of j. So this condition, a of j minus 1 is not greater than a of j. So this condition is violated. So you come out of the for loop. Okay. Again, take the next element. So now the 3 is there at the proper location. Again, take the next element. What is the next element? Is the 10. If you want, you swap them. When I say if you want, if there is a situation, you swap them. Otherwise, leave it. Again, take the next element and keep on doing it until you reach the value n. So from I is equal to 1 up to n, you do that thing. So this, where is this? I will start from I equal to 1 up to the n. So when this outer loop is completed, your elements are all sorted. Once the elements are all sorted, you just print them. Again, this is common for almost all programs. So you just say sorted elements are, and then we will use a for loop. So remember this one. This is true for almost all sorting one. Whenever you have this in fact whenever, what is this, everything is gone. So let me rewrite it. Okay. I less than n I plus plus. So done. So this is common for all programming language, I mean all sorting algorithms. So you just keep it as it is. And a very important thing, keep one space here. So that's very, very important. Whenever you are doing it, keep one space here. Otherwise, what will happen is it will come like 3, 4, 5, 6, something like this. All of them will touch one another. So you need, after 3, you need one space. After 4, you need one space. So that space you have to accommodate it here. And let me write the next part. That is a of I. Yeah, that's all you need to do in this program. Let me save it and let me run it. So this is what you have. Total number of elements. Let me say total number of elements are, let me just zoom in. Total number of elements are 5. So this is generally you're going to do that thing. So you're going to say 10, 3, 0, minus 5, say 2. Sort them. And I'm not getting anything. What is the reason? I did not get anything. What is this? So by mistake, I think I have written I less than 0. This should have been I is equal to 0. So when I talk and do it, sometimes I end up in trouble. Sorry about that. This is I is initialized to I is equal to 0. By mistake, it came as less than. Okay, so let me try it one more time and let me zoom in for you if it is not visible. So let's say 5. You start with the 40 and maybe 8, 0, minus 5, and 25. I'm just putting some values over here. Just press enter and just notice what you have here is the 5, then 0, 8, 35, and 40. So these are in the ascending order. That's it for this program. We will meet again in the other programs. Thank you.